enteric organism is a gram-negative bacillus. It's oxidase negative. It is glucose fermenter. It is reduces nitrate to nitrite. And if it's modal, it has Paratrichus flagella. That's the definition, right? So these media are used for different applications. So the first thing that I'm going to talk about the plates first, and I'm going to talk about oxidase, and then we're going to do the demonstration. But the first one is known as EMB. EMB stands for eosin methylene blue. So in this media, you have the pH indicator eosin. All of these media, because they all the bacteria, all the gram-negative enteric bacteria, all the gram-negative bacilli that are enterics, all ferment glucose. So glucose is not a good tool because they all do it, right? So we go to lactose. Lactose, half of them ferment it and half of them do not. It's a great tool to differentiate them, okay? The other thing is oxidase, and we'll talk about it in a minute. But this one, this medium, has got eosin, it's got methylene blue and bile salts. Methylene blue and bile salts together help to not allow for gram-positives to grow. So gram-positives will not grow on this plate, okay? Only gram-negatives. And bile salts, okay? And of course, lactose is important. It's king for all of these tests for all of the different plates that we're doing. Lactose is the principal substrate. So what you're going to do today for me is you're going to take this particular plate, you're going to divide it into 4 equal parts. You're going to put E. coli on one, just draw one line. You're going to put, what are the others? Enterobacter aerogenes, Enterococcus faecalis. Okay. So, and then you're going to put Salmonella typhimurium, right? If it's a lactose fermenter, it's going to turn red or pink on here. The colony will turn red or pink.
Like E. coli?
E. coli is a fermenter, but because of the addition of methylene blue, E. coli produces a special enzyme. And that special enzyme, Ms. Carolina, will interact with the eosin and the methylene blue, and you're going to get a metallic green sheen with E. coli.
Okay, they turn pink on something.
They turn pink on McConkey.
Okay.
And we're going to talk about it in a minute, okay? But so, hey, Cheska, will you do me a favor? I'm going to give you a special plate. Your group is all going to do just a normal, cut it in with the Sharpie into 4 equal parts. 1 line for Enterobacter, 1 line for Salmonella, 1 line for Enterococcus, and 1 line for E. coli. But you, Cheskinator, if you will please do a 4-quadrant streak for E. coli so that we can see E. coli on here. This particular medium, EMB, was designed to test for water. So you can see that's the first thing that's underlined. Its application is a test for water because it's looking for E. coli because E. coli is a marker for fecal contamination. So we're not testing swimming pools. We're testing rivers and we're testing lakes and places like that. If the numbers of coliforms, or the number of E. coli are up, then we close the waterways. People cannot go swimming, okay? And the reason I hit Keong is you can see right up there for the definition. I said for Keong, because Keong called me on Monday quizzing me about the definition, okay? So, oh.
Yeah, that's right.
It's 2 words.
Okay, my bad.
My group knows.
Okay. I wonder who corrected them all the time.
Oh, yeah, it's nice to meet you.
Okay, so everybody with me?
Yes.
Everybody understands? So if I ask you on the examipu, the practical, what is the application of EMB? You're going to say what? To test for water. Looking for fecal contamination. And the number 1 organism that is the marker for fecal contamination is E. coli. Okay? Good? All right. Let's go to the next one. Hector-1 enteric agar. In Hector-1 enteric agar, again, the principal substrate is lactose. It has a pH indicator, bromothionyl blue. Right? You've used it before in what test? Citrate, not nitrate, citrate. Right? It also has bile salts to inhibit the growth of gram-pos. And then it has ferrosimonium citrate, also known as iron, right? And that's going to pick up the formation of hydrogen sulfide.
Which one is it?
This is Hector-1 enterococcus.
HE.
So check it out. We're going to use this. The application is to test for stools, and what we're looking here for are pathogens. The two big pathogens in stools that are bacteria are Shigella and Salmonella. So really, if it's a fermenter, we don't care about it on this plate because we're looking for pathogens, Shigella and Salmonella. Now, we're not going to bring out Shigella, right? Why are we not going to bring out Shigella?
It's too pathogenic.
It's too communicable. It's bad. 10 cells, you get sick. And I do not want to be known as that professor that there was a major outbreak of Shigella in his microclass. Okay, there's no reason to do that. But what you're going to do here for me is you're going to draw four equal quadrant on this plate. You're going to put these organisms on there. So you're going to put Protea, Salmonella, Enterococcus faecalis, I think. Let me look. Proteus mirabilis, and E. coli, Salmonella, and Enterococcus faecalis. Enterococcus faecalis is gram-pos. Cynthia, is it going to grow on here? No. Right? We put it on there just so that you can see that it's going to inhibit them. Yes, ma'am. Let me get there. No, but you're ahead of me. That's good. I like that. So if the organism shows up as yellow or orange on here, it's a fermenter, and we don't care about it. It's not a pathogen in the GI tract. But if it's a non-fermenter, that means it doesn't have a color to it. Or if it's a non-fermenter that produces hydrogen sulfide, then we worry. So you can see right over here, I put down in here, that we worry if it's a colorless colony because it's a lactose fermenter, non-fermenter, and it could be Shigella. Or if it's colorless colony with black precipitate, we worry because it could be Salmonella. So can you see the organisms you're going to be responsible for on the practical, right? Good. So I might ask, for instance, why is EMB used? And you're going to say, which organism are you trying to find? And you'd say, good. I might say, on Hector-1 enterococcus, if you have a non-lactose fermenter, what potential pathogen could it be? You're going to say Shigella. And if you have a lactose non-fermenter that's H2S positive, then it's what? Salmonella, potentially, right? Good? Everybody with me? What's the application for Hector-1 enterococcus? To test what? What are you going to test?
For pathogens.
Pool. You're going to test stools.
Oh.
Okay? It's right there. See it? Used to test stools. See it? All right. Last one is my favorite. I grew up with this one ever since I was a young budding microbiologist. This is McConkey agar. I can look at this and I can tell a lot about the organism just by how it's growing on here. In this plate, and this is used for all clinical specimens that are not poo, right? But abscesses, whatever, right? Anything that you might have that's potentially could have a gram neg in it, and this is one it uses. It has a new pH indicator called neutral red. The first time you heard about it, okay? Neutral red, when it is fermented, it produces a brick red color. And the brick red color would be kind of like the color of the Bergey's manual, right over there, kind of that hot pinkish color. Yeah, you with me? So if you have that, then it's a lactose fermenter. If it's a colorless colony on here, then it's a non-lactose fermenter. Okay? Good? So you can see I put the ingredients over here: lactose, neutral red, crystal violet, and bile salts are there also, but they're there to inhibit the growth of gram-positive organisms. Okay? So only gram negs will grow here. So if we were doing an unknown, we're not. But if we're doing an unknown and it was growing on this plate, you could assume right away that what? It's gram negative. Mm-hmm. Good?
What were the other two?
Other two what?
So on the EBM, which one was that one? Like they're only gram positive?
All of these plates only grow gram negs.
Okay.
All of them.
All of them. Because they're designed to look for enteric, but have a different application, right? EMB looks for water, Hector-1 stools, and McConkey everything else.
That's what the salt's for, they inhibit the gram-negative drugs, right?
Bile salts, and then there's some other components there also, right?
They inhibit the gram-negative?
Gram-pos.
Yeah,
Okay. Good? Yeah. All right, now, okay. Now, another test that we do is the oxidase test. And the oxidase test will differentiate groups into two different categories. Oxidase positive, oxidase negative. The oxidase reagent, we're going to use a spot test. This is what it looks like. There was an ampule in here. I popped it so that all the reagent comes out. The reagent for the oxidase test is this long. It's NNN4 methyl dimethyl. It's a big old gigantic word, right? On a practical, if I ask you what the reagent for the oxidase test is, your response should be the oxidase reagent, okay? Because I'm not gonna have you know this big old gigantic word, okay? It's not necessary. Good? Jaylyn always says the right thing at the right time, right? Or she gets happy when things she shouldn't get happy. There you go. Good? So if we do this test, we're gonna do it, so I'm gonna divide these up into different categories. All these organisms right here, Proteus, Enterobacter, E. coli, and Salmonella, and Klebsiella, all these 6 guys, they're enterics. Enterococcus faecalis is gram-positive, and the Alkaloides faecalis is a non-enteric. So this particular test will tell us whether something is enteric or non-enteric. If we do this test and it turns purple, that means it's a non-enteric and it's aerobic.
This is for the oxidase.
Yeah. If we do the oxidase test and it doesn't turn purple in 10 seconds, then it's an enteric and it's a facultatively anaerobic organism. Okay? Are you with me? So, Miss Carolina, will you please, this is a sterile cotton swab, if you will take that from the handle and then go in there and get some of the organism for me and then just give it to me after that. So just put it on the swab.
I don't need to like burn the top.
Because it's a sterile swab, just get a little bit of the organism. Thank you. So can everybody see that the organism is on here? So now I'm gonna take the reagent and I'm going to put it on where the organism is. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010. It's turning purple. See it? That means it's a non-enteric and it is aerobic. Okay? Hold that, Gio. Don't eat it. Okay.
You call it positive or negative?
Positive, ox-pos.
And positive is
Non-enteric.
non-enteric.
So pick an organism, one of these, anyone. Okay, so she picked Proteus mirabilis. That's the exact same one they picked this morning. There must be something in the air. Mademoiselle?
It's the closest one, but yeah.
Yeah, okay, it's the closest one. Here, grab the, okay, and go ahead and get a sample. You too could be a microbiologist. Okay, here we go. So now I'm gonna go ahead and put the reagent on there. 1001, 1002, 1003, 1004, 1005, 1006, I'm trying to give it more time, 1007, 1008, 1009, 1010. So can you appreciate that positive, negative? So if you guys will take a picture of this, this can be for your
Data.
This can be for your data, and but let me get it perfect. And then you can just put this. You don't have to do. You can do the test if you want, but this can be your data. Thank you, Miss Carolina. You were awesome.
So we could pick only those two.
You don't have to do this one. I just did them
Just
for you.
don't do it. Okay.
I did them for you. Okay.
Yay!
Good, anybody? Oh my God, there she goes again. Anybody else have questions? Okay.
Picture.
What were those two organisms? I got it.
So this is Alkaloides faecalis. It's a positive one. And this one was Proteus mirabilis, but it would represent anything that's enteric.
So we could say it would be close.
Huh?
No? So
You could say it's E. coli if you wanted to, but it's Proteus. This is the one that she picked. These are all in the same category. These are all enterics. Okay? But you can see the difference in the test, right? So is this particular organism positive, negative?
Positive.
Is it enteric, non-enteric?
No.
Is it aerobic or facultatively anaerobic? Very good. Enteric, non-enteric? Enteric. Okay? Is it facultatively anaerobic or aerobic? See the kinds of questions? That's like 6 questions for the practical right there.
Yay.
You're getting really happy today.
That was negative, right?
It would be negative, right? But that's not the one we used. That's not the one we used. We used this
Oh,
one. Just turn the A.
oh.
Okay. Good?
Wait, it was the aphacy.
Faecalis.
Faecalis, that's the non-purple.
Oh, we stopped.
A faecalis.
Non-purple.
No, purple.
Purple.
So it was.
It was aerobic.
Hey guys, so what does faecalis mean? From feces, that's what it means. So can you see that both of these organisms have faecalis in them? That means that they were derived from feces. But they are not enterics, right? Because the definition of enteric for gram are right over there, right? These guys aren't going to fit that definition. Okay? Good? So what I'm saying, Cheskinator, is that hold on, listen. What I'm saying is there can be a whole bunch of different organisms that are derived from feces or from our intestinal tract, but they do not fit the definition of a gram-negative enteric. That's what that little box over there is, what an enteric is when we talk about gram-negative enterics. Okay? Good? Anybody else want to keep these or want these for anything? Anybody need a picture of it? Are we all done with it? Okay, I'm going to put them in here, and there they go. And I'll recycle those. Okay, so, hey, Cheska, will you do a 4-quadrant streak of E. coli on EMB?
So
So,
we all don't do it?
no, hold on. This is extra. Okay? Everybody's going to do normal stuff, but I'm going to pick a few people to do an extra so that we can see E. coli all by itself. Okay? So, Jaylin, will you do salmonella on Hector enteric agar?
Yes.
4-quadrant streak?
Yes.
And Tamisha,
Yes.
will you do E. coli on McConkey? And the reason E. coli on McConkey is because if you have a red color in here, it's a lactose fermenter. No color, lactose non-fermenter. But if you have a lactose fermenter and it has cloudiness in the media around it, that's called bioprecipitate. And in this lab, only E. coli and Citrobacter do it. And it's right down there. See it? E. coli, Citrobacter. So if we were doing unknowns, we're not doing an unknown, but that would be a real quick characteristic that you could work with to figure out what the organisms are. Hence, guess what? It's going to be on the practical. This is the diagnostic part. This is all critical thought. Okay? Good? Be sure you know everything on the board. It's on the 11. Huh? Oh, I won't erase it because Dr. John and Co. Vanderzee are going to use it later on.
Wait.
They like my stuff, huh?
So with the 4-quadrant, you want it from the big long one?
The big long one.
It's like this one?
For isolation.
Okay, yeah,
Yeah,
that one.
for isolation. Okay? So I've got 3 people. This is for you